We'll now look at solving exponential equations. So essentially an equation with the variable that we're looking for in the exponent. As an example, we could have 5 to the 3 minus 2x equal to 5 to the negative x. And there's going to be two different ways to solve these, and we'll start with the easier form, which is essentially, as long as the bases are the same, then the exponents have to be the same. Here, on both sides of the equation, I have 5 raised to a power. Therefore, those exponents have to be equal to each other. And now I just have a very basic linear equation. I can add 2x to both sides and just get 3. So I have my answer. Let's look at a couple more. Another fairly basic one, 3 to the 2a equal to 3 to the negative a. Once again, the bases are the same, so we can just set the exponents equal. And then I can add a to both sides and get 3a equal to 0. Divide by 3 and just get a is equal to 0. So I have my answer. So now let's look at something just slightly more complicated than this. 8 to the x minus 1 equal to 2 to the x plus 2. You'll notice here my bases are not the same. So I can't just set exponents equal like I have been doing. But it's only one extra step that we have to do now. Essentially, I need to force the bases to be the same. I know that 8 is 2 cubed, so I'm just going to rewrite the 8 as 2 cubed. When we raise a power to a power, we multiply, so 3 times x and then 3 times negative 1. And now that I've done that, my bases are the same, so I can set the exponents equal. 3x minus 3 equal to x plus 2. I can subtract x from both sides. That gives me 2x minus 3 equal to 2. I can add 3 to both sides. That gives me 2x equal to 5. And then dividing both sides by 2 gives me my answer of 5 over 2. So if our bases are not the same, we just need to do this extra step to force them to be the same. Let's do another one. Here, 8 to the 5x equal to 16 to the 3x plus 4. Well, the bases are not the same, so we need to force them to be the same. I can't raise 8 to a nice power to get 16. 8 squared would be 64, and I also can't raise 16 to a nice power to get 8. So instead, we're going to have to find a common base for both of them. So we know that 8 is 2 cubed, so I have 2 cubed to the 5x power, and 16 is 2 to the 4th, so on the right, 2 to the 4th to the 3x plus 4. I can now multiply my exponents. I get 2 to the 15x equal to 2. When I multiply here, 4 times 3x is 12x, and 4 times 4 is 16. And now I have my bases the same. So instead of just changing one, it may be the case that we need to change both. But now I can set them equal. 15x equal to 12x plus 16. I can subtract 12x from both sides. When I do, I get 3x equal to 16, and then dividing both sides by 3 gives me 16 over 3. So I do have my answer. The problem comes when we have equations like this one. 5 to the x equal to 7 to the 2x. Well, I can't write 5 in terms of 7 because 5 to a nice power is not equal to 7. I also can't write 7 in terms of 5. In addition, 5 and 7 are both prime numbers, so I can't write them with the same base at all. So how do we solve this? So we do have the other method, which we'll now address in the next video.